Alright, this video is a pre-lab on the Dissolution Lab that you guys are doing in class. Mainly what we're going to be looking at is what are the factors that affect dissolution. The two main ones we're going to be looking at, surface area, and we're going to be looking at temperature. Now, if you look in your textbook on page 526, okay, chapter 15, section 1C, it goes into detail how surface area is affecting dissolution, specifically the surface area of the solute, how stirring helps, or at least how it affects the rate of dissolution, as well as how temperature affects the rate of dissolution. Alright, so make sure you read over that. It's really short, maybe half a page, just to kind of get a better understanding. I'm going to go over the procedure right now. Now, for this material, for this procedure, these are the materials that you'll be using. Stopwatch, you'll have 300 to 150 milliliter beakers, a thermometer, which will actually be in a water bath. Okay, so you'll have some water baths set throughout the room. They'll already be in there, so you're not really using thermometer, more as just reading the temperatures. And then rock salt and table salt. You'll have a graduated cylinder, 50 to 100 milliliters, and then you'll also have a stir rod or coffee stir, either one. And then lastly, you'll have a triple beam balance. All right. So this lab is broken up into two parts. The first is going to be surface area, and the second one is going to be on temperature. Now, when you guys are working at your lab stations, you're going to have more than one lab partner there, or at least more than one lab group there. You don't both have to be doing surface area at the same time, okay, and you both don't have to do temperature at the same time. So one of you could do temperature, one of you could do surface area. That way you have less congestion at the stock stations. So with the surface area, pretty much what we're looking at is rock salt versus just regular table salt. Okay. Now, obviously, we're going to be dissolving rock salt, we're going to be dissolving table salt, and you're going to be using the stopwatch, okay, to find out how long it takes to dissolve equal masses of table salt and rock salt. So it's important that in both of these cases, the surface area and the temperature, you need to make sure you have the same amount of salt and the same amount of solvent, which is water. That's what you have the graduated cylinder for, to make sure that you have the same amount. Alright? So, and then of course with that surface area, rock salt versus table salt, you'll be timing to find out how long it takes for a certain mass to dissolve all the way. And then with the temperature, you're going to compare a warmer temperature versus a cold temperature versus, of course, room temperature. So you'll actually have a control in this group. Now, this is one of those few labs where you're actually going to have a hypothesis. Okay, so next I'm going to talk about what your observation is, and then I'll give you your problem or your question, and then from there you should be able to give me a hypothesis and prediction. And I need to make sure I see both of those, okay, hypothesis and prediction, as well as the observation and question on page 26 of your notebook. Now, on your calendar or on your table of contents, it says solubility notes, but I wanted to go ahead and interject a lab before we start talking about solubility. Okay. So first is your observation, which is temperature and solute surface area affect the rate of dissolution. So make sure you write that down in your notebook. Okay, your question. Under which conditions will the rate of dissolution be the fastest? Meaning, what's going to cause the fastest rate? Now, remember, for your hypothesis, okay, all you're going to do is just answer the question. You can say anything along the lines of room temperature and table salt surface area, or you can say warm water and rock salt temperature, or warm temperature and rock salt surface area. Okay, any combination of those two. So you're really testing two variables right here. You're going to test for temperature, right? Temperature right here, and you're also doing surface area. So you're telling me with those two factors, under which conditions would the rate of dissolution be the fastest? All right. Now your prediction is going to be an if-then statement. Now remember, when you're writing out your if-then statement, there is no personal pronouns. When you're writing out your hypothesis, you don't write personal pronouns. You don't tell me, me, our, we, anything like that. Okay? Don't tell me what you think. Don't say, I think. Okay? If I see, I think, you will automatically lose the points for this portion. Okay? You are beyond thinking. You can actually just state what's going to happen. Okay? So answer the question. That's your hypothesis. I don't want to see I think, or I believe, or we think. All right? No personal pronouns in there. Just tell me. This blah, blah, blah is going to be the best condition in which dissolution would be the fastest, or the rate of dissolution would be the fastest. And then if this happens, then this happens. So you guys already know an idea as to what your procedure is, so you should be able to answer the if and then portion of that prediction. All right? In case you haven't figured it out, yes, this is going to be your first full lab write-up. Okay? I will give you more time, and we will actually do this together. This is a simple lab. I'm sure you guys can be all, I'm sure none of your hypotheses are going to be rejected by the time this lab is done, but I still want to walk you through it step by step, okay? Because there are going to be some labs where when you do a formal lab write-up, you will you'll want to follow these steps that we do as we do them together. All right, so in your notebook, on page 26, I want to see an observation, a question, hypothesis, or prediction. If I don't see those four things, you won't be doing the lab.